The second part of step 2 talks about solving inequalities, and there's really not a big difference between the two, except instead of the equal sign we have the inequality symbol to take into consideration. The first thing I want to point out to you is this key concept here on the left. This is something you find in your math textbook, but I want to make sure that you're able to make some sense of it, because I don't know about you, but when I was younger I would see all these letters and it meant very little and I had a hard time understanding it. But let me explain what it means. Whenever you see something, whether it's on a standardized test or a test you take in Algebra 2, if it looks a little too abstract, go ahead and put some numbers in, okay? If we let A be 7 and B be 3 and C be 2 maybe, I would just pick those at random, okay? If 7 is bigger than 3, then 7 plus 2 is bigger than 3 plus 2. Is that true? Yeah. 9 is bigger than 5. And this one just says the opposite. If you have a number smaller than another number and you add something to both sides, the left side is still smaller than the right side. Similarly, if we subtract, so if you have a big number and a little number, this is bigger than this number because of the greater than, and you subtract the same thing from both sides, the left side will still be larger than the right side. Now, when we try to multiply or divide, that's when it gets a little more interesting when we're dealing with inequalities. For instance, if you have negative numbers or positive numbers and you multiply by a positive, the inequality symbol doesn't change. So I could have 5 greater than 3. I could make them positive. And multiply 5 times 6, it's still going to be greater than 3 times 6. 30 is going to be greater than 18. Notice we are multiplying by a positive, the symbol stays the same. Multiplying by a positive, the symbol stays the same. It doesn't matter what the original numbers were. It matters what we multiply by. On the contrary, look what happens down here when we multiply by a negative. The inequality symbol flips. It starts out greater than and it ends up less than. The same thing happens when we divide. When we divide by a positive number, nothing happens. When we divide by a negative number, the symbol starts out less than and ends up greater than. It flips, it switches. Let's apply that and see about solving some of these. I'm actually going to start with the second inequality. So looking at this second inequality, you can still divide your inequality into two sides, just like we did with equations, if that helps. We're solving, there's that same part, we want to get W by itself. Well, we have W's on the left and W's on the right. Personally, I like to always try to get my letters on the left, but you don't have to. It's just one way to do it. So I want to move all the W's to the left side. So I'm going to subtract 4W. So 5 wheels, take away 4 wheels is 1 wheel. Notice I don't have to put a 1 before it. 3, it's still greater than, all I've done is subtract something and that doesn't change anything. And 9. I'm still trying to get W by itself. I have to get rid of the 3, so I'm going to subtract 3. W is greater than 6. That's my final answer. Pause your video and try these other two inequalities, one on the left, one on the right, and see if you get the same thing. Okay, you should have gotten y is less than 9 for the first one on the left, and over here on the right, you should have ended up with x is greater than 5 when you solve. Notice our inequality symbols haven't flipped because we have not multiplied or divided by a negative at this point. Let's try this next one. I'm going to divide by negative 4.2 on both sides. That's how I'm going to isolate x. Currently has times negative 4.2. When I divide, cancels out, I'm left with x, but notice I'm dividing by a negative, so I immediately need to flip that symbol before I even go over to my calculator to figure out what 29.4 divided by 4.2 equals. Calculator, when we divide those, we end up with positive 7. Go ahead and try the next two. Pause your video, see if you get the same thing. In both of these examples, we're dividing by a negative, so our inequality symbol is going to flip in both cases, from greater than or equal to less than or equal to, and vice versa. Let's try a multi-step equation. Multi-step inequality, rather. Here I'm trying to isolate C. On the left side, it doesn't have very much keeping it company, but on the right side we have a lot going on. We have a 5, a 58, and a 6. The first thing I'm going to do is get rid of this fraction by multiplying both sides by 6. On the left, I'll have negative 24c is less than or equal to, I'm not flipping my symbol because that's a positive 6, 5c plus 58. Again, I prefer to keep my letters on the left, so I'm going to subtract 5c because I need to get the c terms together. That gives me negative 29c is less than or equal to 58. Now you might say, wait a minute, that was a minus 5c. Yes, but we are subtracting it. We are not multiplying or dividing by it, so we're not going to flip the symbol. Then I'm going to divide by negative 29 on both sides, which means I'm instantly going to flip my symbol because I'm now dividing by a negative. I have c is greater than or equal to negative 2 for my answer. Try these next two and see if you get the same thing after you pause the video. Alright, on these next two I tried to point out when we need to flip our symbol. It happened right here when we divided by a negative, so I wrote the word flip. On the second example that you should have tried by yourself, I had to flip my symbol twice based on the way that I solved. First, when I multiplied by a negative 4, and then when I divided by a negative 28. So it flipped to less than, and then it flipped back to greater than. There's two more to try that involve some distributive property. Go ahead and pause the video. Try these examples and see if you get the same thing. Alright, a couple of important things I want to point out on these examples. Notice right here, I'm taking negative 6 and multiplying it by each term inside the parentheses. That is not the same as multiplying both sides of an inequality by a negative number. So we do not flip the symbol because we are multiplying by a negative on one side. That does not affect anything. It only affects things when we do the same multiplication or division by a negative on both sides. Let's apply what we know about solving inequalities to solving a word problem about an inequality. Enrique's company pays Salim to advertise on Salim's website. Salim's website earns $15 per month plus 5 cents every time a visitor clicks on the advertisement. What is the least number of clicks per month that Salim needs in order to earn at least $50 per month? So let's think first about how we're going to earn money. So how do you earn the money? Well, you take 15 and a nickel every time someone clicks. So if it clicks once, you add 1 nickel. If it clicks twice, you would multiply that by 2 and add 2 nickels. If it's 3 times, you will multiply it by 3 and add that. Notice that we're going to be multiplying by the number of times, and we don't know how many clicks or how many times that happens. So we're going to use a variable. And we want this amount. This is the amount of money That's the amount of money. We want it to be at least $50 per month. So we need to compare these two. And it's okay to just try with an inequality symbol and see which one works. But think about it too. If you have at least $50 in your pocket, do you have more than 50? Equal to 50? Less than 50? What would you have? You might have exactly 50 or more than 50. That's what at least means. At least can be translated to a greater than or equal to symbol. At most, if you see those words, at most, it would be less than or equal to. Kind of seems counterintuitive because less than goes with most and greater than goes with least when we're talking about at least, at most. All right, so let's try to solve this. First, we have to subtract 15 from both sides. And when I do that, I'm left with the nickel times x greater than or equal to 35. And then I'm going to divide by 0.5 on both sides. $700, I believe. So he needs at least 700 clicks to earn at least $50 per month. Rose's internet radio plan costs her $9.95 per month. There's that $9.95 per month. She pays that every month. 1 month times 1. 2 months you would double it. 3 months you would triple it. So we have to do $9.95 per month plus 88 cents for each song she buys. So if it's 1 song, 2 songs, and so on. So now we probably should have read the entire problem before we just started writing. It is $9.95 per month, but I believe this is asking for 1 month or in 1 month. So it's $9.95 for the plan plus 88 cents for each song per song. That's where we want to put the variable. How many songs can she buy and still pay less than a total of $20? So this is how much it costs, and we want that to be less than 20. We want the cost to be less than 20. So I need to subtract $9.95 from both sides. I'm left with 88 times x. And that's going to be $10.05. Let's use our calculator to solve the rest. We're going to do $10.05 divided by 88 cents. $10.05 divided by 88 cents. 11.42. So this is the number of songs. Can you have 0.42 songs? You really can't. So let's think about what this really means. Less than 11.42. So can she buy 1? Yes. 2, 3, 4, and so on, all the way up till 11, but she can't afford 12. So 11 or less. is what she can afford and still pay less than $20 in 1 month.